Good morning. So now I have an hour or 55 minutes. Right. Okay. Yeah. All right. So what I wanted to talk about today is the product that we briefly announced yesterday, and it's all about a client way of looking at things. How do clients see the network, right? So we're going to go through a couple of PowerPoint slides, and then I'm going to jump into a live demo, right? You all got a USB stick, which is a license. We license it in this way. All right. So we license it this way. So you have a USB stick, and there's this AirMobile collector there, and so you can just run it on any PC. Not that complicated at all. It sits there, and the way it looks is if we go here. So what does it do? Basically, it starts with pinging two locations. Yeah, all right. Pinging two locations. These are here. We plugged in here. That's the gateway. That's the local gateway for the hotel network, if you're using one, right? And it says 5 milliseconds. Oh, sorry, 5 seconds. That's the ping interval. Every 5th second, there's a ping sent to this address. All right. At the same time, there's another host. We chose AirMobile.se. Could be Google.com, but in real life, it would be your sort of. Well, the first would be a near IP, and then would be far end IP. It could be a application critical server, something that you would like to verify connectivity to. So 2 locations at the same time. Then you choose which card it runs on. There's only one on my PC, Wi-Fi that is. And basically, there's all you need to know right now. Oh, maybe upload settings. So with 1 minute interval, we're sending data to this server. You're going to get possibility to log in there after the session, and so you can see your own data and somebody else's data. It's kind of, let's have fun together approach. So let me go back to the presentation from now on. We're going to be going back to this as well. So the client settings, here's the screen. The previous screen, well, I think we explained it. One thing I did not say is that here you get some sort of a live information. So every 5th second, if you choose 5-second interval, you're going to get some, data. So you see it's alive. Then again, in a real life, it sits in the background and nobody's concerned with that. And it's just for us to set it properly and see whether it's kind of going. So what is it really? I mentioned at the beginning. So what we do believe is, okay, you can test your network and see how it performs, but it's in the end the client that sort of masks all this behavior. The client has a problem quite often, more often than not. It will cause in very, very bad quality of experience for the end user. And while we have good visibility when it comes to network infrastructure, we have very little normally when it comes to clients. But then again, where's the problem, network or client? That you would really like to know. So what do we do? Imagine you have those PCs running somewhere there. One of them is yours. They connect to access points, and in this slide, you see we have a local gateway, which is quite often the case. And then you have another test towards some sort of application server you would like to verify whether it's still on or not, right? So there are logs being created. So on this USB, when you run it, one day will be a log like a CSV file. This is the file that is continuously being sent up to a server with 1 minute interval. So it's just incrementing it. So these guys go to a server or analyzer, as it's called, and then you have a number of interesting things to look at. We're going to do it pretty soon, right? So yeah, I think we're going to flip over through this and have a real life examples. I just want to mention that we now run an SQL database. In the background, we have some people doing some sort of business intelligence, just getting the data from the database and trying to further analyze the data and get their angle on things. So it doesn't have to be like we are presenting it, right? Well, I really wanted to test it, and some people thought, no, we don't do it. So we're going to do it. We dive in right away. I have a few slides more to come after that, but that will be just kind of a wrap up. All right. So normally you log in. You see, WLPC.airmobile.se is the website, and what you see is you see. Oh, there you go. You see, when you first log in, you see something to call an SLA. It's a calendar type of view, and then you see a day, and then each day has some parameters. So this is yesterday. This is today, right? So what does it tell us about yesterday? It tells us there were 21 alarms, if you will. It tells us there were 9 different clients reporting. So not that many of you were willing to, but that's okay. It's actually got a really nice data. I hope we'll have a nice case study there. And 5 of them didn't really match the required SLA. It doesn't look all that good, partly because when I looked at data, I saw that some of you guys did not use the hotel network. We used the WLPC network. And then again, in this case, the IPU pinging, the first one IP, the gateway, wouldn't be valid. So you would have ping loss towards that server, obviously. Right? So what can we do? So that's the kind of top-level view on things. So if you go and click on these alarms, you're going to go to something that's called Advisor for that particular day. So what it does, it lists alarms, as we call it. So these are those disconnections as they happened, right? So you have, say, this one. At this time, duration was that long, 2 hours. Again, part of it could be due to this another gateway they're using. Which AP was it? A client who can have an alias. Which channel? And we have some sort of intelligence trying to give you some tips. What could that be? We can go back to that after. Each of those events have analysis button to dig further into the data. But before we do that, I wanted to go to coverage, right? By the way, all these columns you can sort, so that's duration. Kind of makes sense. Show me the longest, the biggest problem at the top. But you can say, all right, show me channels. Okay, there was something there, 36, right? Or a client. Oh, Matthias, doesn't look good for you. Not for me either. Well, duration it is normally. If I go to coverage, which is some sort of a table telling you, summarizing what we've seen. And that's all client-based data. So what we're looking at, we're looking at all those clients and access points. So clients, there were like 8 of those, 9, and their connection failure time. Again, what is the time that they did not perform? That we're going to go to settings and see what that means. What is how much is it in percent? So 12%, that's not very good. Average RSSI for that client. So if you're looking at average RSSI, that's actually interesting thing to look at. You can sort it and say, yeah, that's my yoga. That has a strange RSSI. Now we're touching to another thing, where RSSI is actually something that well, it depends. We just take it from the card. If the card tells you in dBMs, you have a dBm value. If that's what it gives you, that's what you get, right? But if you just take away this, you'll see that there's a number of other stations, and they're roughly, there's a good signal strength. Nothing to worry about. The next line here is average available access points. That's an interesting metrics, because when they scan around, they will try to see the neighbors that belong to the same network. So on the average, this guy sees 6.3 access points, right? For that particular day. Well, it could help you. It could help you, especially when you're looking, say, the same metrics that are available for access points. And again, the data comes from the clients. So how would you read it? If I just go like this. So there are some of the access points where there is no extra access point to connect to. So if the clients are connected to this BSS ID or this, or this, or this, there's only one access point. This access point itself, nothing else. So should this fail, there's nowhere they can roam to, right? And it has to do with the fact that you set up a different SSIDs, and that might be just a unique BSS ID with just one access point running it. And there are some other ones, if you sort it here. Here's like, wow, this doesn't seem to have a problem with that. So that's just a table, but I think we all are more interested in going to analysis, really. Show me what happened. Show me why, and let's analyze it really, the data. And we can come back here, but if we go back to Advisor, we keep the same day, which is yesterday. I think I went through this data yesterday, and I found this really, really particularly interesting. This one. As I say, a lot of those errors come from the fact that we're pinging the wrong gateway, which is sort of, not what you want to look at. So we go to analysis. What it does, it takes us to analysis view. Surprise, surprise. Which is, to begin with, your ping graph. Zoomed on this particular event. So what are we looking at? That's the ping times. To begin with, very simple, no RF data. Towards two hosts. You see the red one is the gateway, and the green one, it's AirMobile.se, but it could be your application server. So if things are okay, here, you have the values you would expect. You have like 2.5, 2 milliseconds towards the gateway, 40 milliseconds towards your application server. But somewhere here, things go bad, right? And see the time. What happened just after 5 p.m. yesterday? Right. We have this building session. So this particular PC, I mean, if we stretch it out, just to give us a little bit of perspective here, because we don't have to be looking at this, it was doing okay. Oh, there's a little glitch here. But it was doing okay, right? Until this thing came. It couldn't cope with it. I'm just looking there. I wish Rob was there, because look, wouldn't you like to know this for some of your clients and maybe exchange your students with that? But okay, what do we see in here? We see there's this BSSI indicator, so basically roaming in between, right? Somewhere here, things at the client decided to roam. I thought it's not really working really nicely for me, so let me roam to something else. Okay, let's see. It didn't get any better. So, but let's look. It's all aligned here. We have RF data here, right? So, if you're looking at this, and I maybe get a bigger perspective again. So there's two radio parameters we get. The red one is RSSI. Here's the scale. And the green one is SQ, signal quality. That's what Windows gives us through Windows APIs. So we'd like to have signal-to-noise ratio, right? But that's as good as you can get. So, okay, we can see that signal RSSI is kind of the same here, but when we started doing things, the signal quality went down. The radio saw interferences. You can guess that something happened there. So that would be, you could think, a primary reason for those times going up, right? sometimes when you see one of the pings going up and one staying in a proper like 2-3 milliseconds value, you know, all right, the Wi-Fi works. I can ping my gateway, but I'm not going any further. So at least you know Wi-Fi is okay. You can say, yeah, the problem is somewhere else. But that's not the case in general in this particular case, right? So again, now this is where client decided to roam. It's actually interesting. And again, I remember what Rob said yesterday. He said, all right, the clients typically roam at -65 or whatever, but now it did roam even if it was like -46, 48. So that's kind of stays in line with what he presented, saying that, well, there's a lot of traffic. They try to find a better channel anyway, a better access point. And that's what this client did. It did roam, right? Here was the roaming event. The ping times did not get much better. I just stretch it out. So that's our ping event. It didn't get much better. The radio, yeah, it went somewhat better here. Signal quality, a little bit. But RSSI, a little bit. However, this is the real thing. Okay, what else can we see there? We have this table. So this table is basically the raw data as it comes from our collectors. And what we see here is a timestamp, the host you're pinging, -1 is a ping. It's the way for us to say that it's like ping loss. Nothing comes through from that particular host. From that host, you have ping number 2. Then you have SSID. Then you have a BSSID, channel, signal quality, RSSI. And then you have this RSSI list, which is the neighbors that have the same SSID, right? So they do belong to the same network. So your client could potentially choose one of those. So, yeah, was there a question? No? Okay. So this is the data we see. And if we carry on here, we see that, all right, it came from this, I don't know, that's 23. It went back to 9A. That's the same color. It's 9A. It went back here. It wasn't happy with this. And look, the time scale. It's like 40 minutes. 5:10 to 5:50, roughly. It wasn't going any good for this particular client. But this, if we put ourselves here, this is where well, now we know what it is, started working or connected towards the mini computer, right? So that would explain that there's a very good explanation when you couldn't ping anywhere from there. Right? You see this color. So we have those fixed settings, and then obviously this time it kind of excluded. But let me see what happens there. So it's there, and obviously our data is -1 and -1, meaning ping lost to both of the servers. Here's the SSID, here is the BSSID channel. Signal quality is excellent, RSI is excellent, and you have just one access point. Surprise, surprise. There's one access point that belongs to that network. And of course the value would be sort of the same. There might be some differences, because what we see actually is those values typically come from, you know, Windows. Every now and then they do scan networks or for the same network just to prepare before roaming events, so build a database. So this data could be old, so obviously don't do it so often. RSSI is fresh, because you still all the time maintain the RSSI value towards your current access point. Well, of all, if we click elsewhere, say here, so you have in this case, you have like 3 access points, right? Or more. So that's a total number, including the one you already connected to. And that was the number, if you remember, in this column, telling you how many neighbors you have. So that was the average of that. So we take a data for that particular client, for that particular day, whenever it was reporting, and giving you the average. Well, it's actually a lot of interesting things that can happen. You can see that some clients are very lively. They would like to see scan for new access points. They would like to build this table quite actively, proactively. Some others are, they sit happy. If they're happy, they're happy. They don't do much of a scanning there, really. And then the interesting here is, okay, we have the blue one is obviously the PC you would test the test will run against, and then you come back to this, the green one, and then obviously you get the connectivity again, and then somehow it chooses to roam again. Couldn't tell why, but it roams. I found it here. There's a lot of roaming events. I don't know whether it has to do anything with the network, or it seems like clients seem to roam with no particular reason. But then again, we have visibility in some of the things, not all.
Just had a question for you. It looks like the data shows at 1810 you roamed to a different channel while you still had really good ping times.
Right.
But you actually went to an AP with the lower RSSI. Correct.
So here, yes, it did. And I've seen a lot of those. Normally, that's not the case. Could we say that perhaps this particular client roaming algorithm are, of course, based on RSSI, but perhaps something else?
Obviously something else.
As well. So it could be, I don't know, TX rate upwards, like uplink, or it could be, I don't know, retries, things like that. We don't know that, right? That's kind of a black box, roaming algorithm.
But the part about this is you're seeing something you don't normally have active.
No, yeah, that's correct. So you can see that. I guess I owe some explanation here for this view, because we did a little bit of a tricky approach here. We have two values to play around. I'm saying this because you all are going to get access to this for like at least to the next conference. With your single license, you can play around. Again, the idea is we dump the data to a common space, common area, so you can see somebody else's data. That's not a problem, I hope. You can learn how to use it. You can use it for your own debugging purposes or whatever purposes that might be. So what we did, you see, the pings normally, we noticed, there's no physical value with the pings. It's not like temperature that goes up and down very slowly. It's not like RSSI that is kind of going up and down slow. Pings, one ping could be 1 millisecond, the next one could be ping drop. So we average those things, right? So it's smoothing factor. That's just a moving average for this particular view. What happens if we run 1, which is no averaging, obviously. So this is how it looked in reality. That's one part of the explanation. Another part of the explanation is, what do we do when we have no answers, like ping timeouts? We try different things, actually. You could have, like, you stop drawing this altogether, but you don't see them very much. You can have a vertical red line telling you this is where it didn't go through. But we decided to do something else. We decided to give a ping loss a value. I know it sounds strange. So these values there, or actually this value, which you can change, is normally 150% of a worse ping. So whatever the ping was, say it was roughly 2,000 milliseconds. It took 150% of that, and this is the value for your ping loss. So if you use it together with smoothing factor, it's so easy. If you look at the entire day, it's so easy to pick up the worst moments. Because you see this one, how it's building up. If I just take out the smoothing factor, you see those just, if I zoom in here, it went obviously right away to ping loss. But it was averaging over 10 samples, and it was a moving average, so you see this slope growing up until it gets to the top, which means you had 10 consecutive ping losses. So it's very intuitive, we think, to find it directly. You're just there. Whenever it reaches the top, you're already there at 10 ping losses. And there's another way of looking at it. That's the entire day. If you look, I'm not sure, say 100, you can have a long time trending on this. Say every time lunchtime something happens. Right? Interesting. So it's a nice feature. You might want to, you can change them. Just viewing, presenting the data, just to give you a better example, what you're after. Are you after long time trending? Or are you normally, when you zoomed in and analyzing dot for dot, then you're probably better off not averaging at all. So that would be one smoothing factor. So that's that. And all right, we we have possibility to, if I go here, so you see, we know who that was, right? So we can go to settings. I wanted to explain a couple of things because you're going to use it, right? Hopefully. So that client is what? It's 4C. So you can go to settings. And here's aliases 4C. Where's that? Here. So you can say. And save it, right? So if we now come back, it can be like this as well. You're going to have, hopefully, Martin's PC here. So all these MAC addresses now. So it's easy for you to find a client, so you know which one to switch. So going back to settings one more time, and walking you through what we do really. Alarm condition. This is where we have those clocks and telling you there was like 20 events today that did not work correctly. So this is, you can set it. So whatever, we work in number of pings as a time unit. So the quickest we can go is 5-second interval. This has a lot to do, like when we send out pings, it can be quite long, and normally we realize that Windows has an upper limit of 4 seconds to get the data back, otherwise it kind of drops it all. So it said, okay, 5 minutes, you cannot do it more often. Then again, you don't really want to destroy your network with pings either. So 5 seconds it is, so that means in 50 seconds, if you have consecutive 10 pings over 150, that's pretty bad actually. Oh, well, it depends. You can set it, obviously. So you set it yourself. Now, when we play around, this is a global setting, so whenever somebody changes it, your data presentation will change, obviously, as well. Then you can send an email. It's nothing very sophisticated, just sending an email whenever that happens. You have an email list, which again is global for this particular console. So that's the alarm condition. That's what we count as a separate event. We're listed in the list of those events, and we can go to analysis all the way to the right. But we also count something else. Connection failures. I mean, we have this SLA approach. You would like to see, say, your service level is 99.9 or 99.3. So what we do is we say, okay, when do we break this SLA? Whenever we have more than 2 pings over 150, we already start counting this time. This is the time that things don't work as they should. And then we accumulate that time over a day and give you the percentage. So there's no alarm. I mean, you could, but that happens quite frequently if you set those 2 ping values. And normally it's something to give you this global number on the main page, SLA page. So you would then see 8972 for that particular day, right? So that's the story. I'm just trying to think if there's something else I should go. Yeah, advisor. Advisor. That's a big name for a couple of algorithms. It's basically things telling you, like there was like roaming related things, like whenever our alarm starts when you connect it to one BSSID, and then ends up when it's another, we declare the roaming related event. So, well, so that you know that during this there was a roaming. It doesn't have to be a cause. It could be a symptom. It could be anything. It's just that it happened during the roaming. Then we have sticky client algorithm. Last year, I believe, I had quite a nice presentation. It wasn't live. It was PowerPoint slides on sticky clients. So basically it says, whenever you're holding to an access point which is below -80, and you have other access points, at least in this delta 25 dB stronger, we know that from the neighbors list, and you're still holding on to this one, we declare a sticky client. You could change that. That's very rough. I mean, you would probably see a sticky client type of behavior with a lot less than 25 dB difference. But then again, when we say it's sticky client, it probably is. So, but then again, you can use it the way you like. And then you have host issue. This is where you have basically one of the hosts answers, the other don't, the other doesn't. We have a lot of customers that say, yeah, the Wi-Fi doesn't work, as usual. I think with your words, like whatever connects to an access point, and when you have a problem, it's a Wi-Fi problem. So you say, no, Wi-Fi works. And this is your host issue, telling you that more or less one ping went beautifully, like 2-3 milliseconds, and the other one went through the roof, or they were like ping losses all the time. And then if, we have this problem with this router, and surprise, surprise, it happened for all the clients at the same time, of course. Because that was a global issue, not just a client issue in that particular case. What I forgot is coverage insufficiency. It's very similar to this, however much simpler. If you don't have any other access point, and you're below -80, right? Then it means that there's no other access point to go to. And if there's a alarm generated, we give it a tag coverage insufficiency. Because we do think that this was caused by coverage insufficiency. You're holding to an access point, you have nobody else, no other access point, and you have -80 or lower. So that's not like a rocket science exactly. SMTP, that's the one we have. So we just hope you're not going to use it as a spam generator. Collector connection. So in this collector, which is the exe file you run on your PC, so the brave ones did, you have basically 2 things to enter. And these are those. Well, actually 3. How often you send the data. We would buffer the data. Remember, it was 1 minute. So whatever you did during 1 minute, up. If it doesn't work, obviously sometimes it doesn't because you have those alarms, right? So when you're offline, everything is stored, and then it's sent up. So analyze the server and the port number. We thought a lower port number is good because you are less likely to have firewall issues. We started with high numbers, and a lot of customers, you know what, I have to go, setting up this, it was very easy. You don't need any endpoints, you can ping right away. And they were like, we have to take those files, the log files, and upload them through the GUI, which you can do as well. You would then do it through logs, we call them logs, and upload logs. And then we'll just end up here. So one log, a concept of log is data that came from one particular client or MAC address for 1 day. So it'll just, if you carry on running, it'll go to midnight, and then it'll close the file, and it'll start a new log. So the log is maximum 1 day. Could be shorter. Most of the times it is, actually. I saw another interesting thing. If we can go, clicking on the lower part will take you to logs directly. So I think it was this one. And you don't have to say where you are, but I like the dedication to testing. So that was it today? Yeah, I think it was today. Let's start with the usual stuff. See the data. There's no problems here, generally. I mean, okay, there are some peaks there, but look at the scale. We're looking at, well below 100 milliseconds. What is interesting, though, it's middle of the night, how it roams. Why? I don't know. Let's look. So here is the first roam. Let's go to the smoothing factor. I'm sorry. RF. Well, explain that. It went from -40 to -52, the red one. And as a result, the signal quality went from 99 to 88. Cool, right? I don't know why, but it did. Then again, we don't have visibility to all, but say if you're running multiple of those, doesn't have to be each and every client, right? It could be, say, 10 of them, and you're playing around with features, 11V, 11K. How do they roam? Do they follow? Because we are agnostic. I mean, we sit on the top of everything that the client does. Do we have 5 gig support? Yes. Do we have 11K support? Yes. Or no, depending if the client can do it. Because we're above all this, right? So that was a strange roam, middle of the night. If you carry on, we can zoom out a bit. There was 2 roams. So, well, it thought, okay, let me go back to this one, the stronger one. It did for a very short while, and then went back there. I don't know why, but that's okay, I guess. I would think. I think the funny part here is some of you are already laughing, is that the host we are pinging. And again, that's fine. I like the, normally we would say ping the important ones, the application critical. So there was apparently, you know, you don't have a local gateway. You have this one instead. And then you have AirMobile.se. I mean, okay, business and pleasure. Well, anyway, so the thing is, you would, obviously you can choose that yourself and depending what you want to test. Our experience says that quite often it's not that great to ping your local gateway if you have a lot of clients, because the local gateways, they prioritize, you know, forwarding traffic. That's what they're made for. Turning around packets could take a while. So you might end up having lower pings from your remote server than from a gateway. And there's nothing to do with gateway being further away or anything. It takes time for it to turn away the packet and send the response to you. So you might want to ping another PC or something else that is, you know, is going to handle the ping traffic pretty well, like local thing. And the idea is very simple again. Of course, you can choose it, but the idea is let's have something that the nearest thing you can ping and then your application critical server. But it's up to you to choose it. I think that's kind of more or less it, really. For the demo, then I have a couple more slides. Questions, comments? Go ahead. Aha, I don't have a mic, of course. Okay. All right. Yeah, I mean, you can use whatever you like, obviously. And then again, if we go to settings, that's a good question. Yeah, that's kind of a part of a problem. You go in there and change it. All of the other guys will not be able to send it, the data to it. So, well, it's probably not the system, the way it's laid out right now. It's, you know, not towards community type of testing. Yeah, and we just set up a dedicated server just for you guys. Right, I'll do that. That's actually a pretty good idea. And another thing I thought about when you just said that, or actually a couple milliseconds before, was that, like, don't delete the data, or at least don't delete somebody else's data. That would be a nice thing to have. And don't change the password, because that would also mess up things. Right? But yeah, we'll do that. We'll do that. But it's kind of common sense, I would assume. Or, I don't know. Yeah? That would change everyone. It's a listening port. So this would be listening on that port. And of course, as long as you know which port that is, you would then go, we can just take that and say settings. This is where you are looking at. So upload settings. So if you kill it, upload settings, you can go through this and say, all right, this is where we're listening. This is the port you want to talk to. So, I mean, as long as this follows, no problem. But then again, it's difficult to enforce that when you have like 100 people trying to follow that. And as I say, it's basically it. I think it's interesting to see what happens when you have a lot of those clients on the same network, and you don't have those silly errors where you're pinging the wrong gateway and everything, because that kind of spoils your stats, because it does. So when you set it up properly, you can basically see and compare. What we do is say like 2 or 3 for each type of clients, and just see how it goes. You build understanding what the normal thing is after a day or two, and then you see anything that sticks out rather quickly. Yeah, all this, what we do, ends up in an SQL database. And as I say, we working with partners and with customers to get the data from the database. And that's getting to the next step, trying to analyze the data on a larger scale a bit. Because you have a lot of data here. Could be very, very valuable. right? So if you just can compare things against things, you can learn a lot of things. So back to the presentation. I survived the presentation. That's good. So now you can know where to go. That's a multi-user, obviously, but then if everybody went, I don't know, we test like 3, 4, 5 consecutive concurrent connections. Then, so basically go there, use the admin, use the password, and you're there. And you can see whatever this is where we were at, looking at the data. Free to use. Just think about it. Don't change too many things. We're going to send out an email. Think that your data is also available to others. So that's... You see? You have to flip it. Coming. I know. I see it coming. We've had it for a while. We kind of waited, and there's like 2 more coming relatively soon, I hope. So that's the answer to it. Okay, so I think I already said that. So it will stay there for a while, the server, unless it crashes. Then we take it as a beta testing and report to you and set up a new server. And then maybe half of the data is gone, or all of the data. No. So just go on and use it. Feel free to post questions and contact us if you feel like that's something what you want to do. We will like to help. We have, for guys like you, we have done something like this, which is a little server, and then we have like a package of 3 of those. But that's we license them currently on those USBs. So that's like how you can grow, and any USB client could go anywhere. And again, that's just a memory. That's just an exe file and some setting files, and all the logs end up there. So you're basically as far as possible from the actual PC, in a sense that you don't have to go through. Quite often, I don't know whether that's your experience, where you go to big customers, say, we have this image for all our PCs, and to change it, if you want to install something, that would take 2 months or 3, depending how it lines up. I mean, kind of exaggerating, but not much. It's a big process. So we have just an exe file. You don't install anything. You don't have to do that. You just double-click it, and you get it to auto start or start up, and just if you feel like it, and it runs in the background. All right. Any further questions?
Any questions?
Carry on. Yeah, go on.
Yell, Anders. It'll take a while to get back there.
Shout it out.
Right. Have you had requesting something like other type of traffic testing? I mean, you could, for instance, want to try to test a specific application, and you typically have set it up with quality of service, so you want to make sure that that type of traffic
is getting through correctly. Right? Yeah, that comes probably not like top 3, but maybe top 5 questions, like a feature request. We thought about it, and that's probably going to make it in some form, because that's what you would like to see. This is basic connectivity test, right? Right now, as it is. Because most of our current customers, they realize that this is our problems quite a lot. The industry or the operators, it just doesn't work. Wi-Fi doesn't work. And you might have a lot of things you can do when you're on site. When you're off site, you cannot do it. You cannot just think to go there and do the testing, right? I'm just looking at time. Right. Let me see. That was, I believe, here somewhere. 2.3.1. Oh. Right. That's what I mean. It's coming very, 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 very soon. It's one of the top of the list. It is top 1, top 2 maybe. To see what was the version and what is the host name and those kind of stats so that you understand what you've done. Because now when you do like kind of focus testing, say version 3 contra version 4, you sort of have to know about it. So if you know which is which, it might take like 3 of the same hardware to you of the version 3 of version 4, run it for a week or two, maybe a day or two, and already there you see the difference. And you know, all right, these guys don't roam, or roam badly, or whatever. So yeah, it's coming, really, really soon. Hopefully to the next WLPC in Phoenix. All right.
Doesn't matter. Does, and then doesn't. Yeah.
There is Renee, I think. It does. That's true. Yeah, that's correct. Well, we're looking at other operating systems. You said Linux, right? Or what do you say? Mac. Yeah, yeah. It's like, right. That's exactly. we kind of limited resources, but yes, again, top on the list is Android, Windows CE. Don't laugh, or go ahead. There's a lot of those scanners, like barcode scanners. You know that. So this is where this seems to be extremely important. And I couldn't. It's amazing how long time they survive out there, and there seems to be new ones coming, and still Windows CE or Windows Mobile. What was the next one? So, and they probably have problems, or we know they have problems, and we just want to, you know. Yes, correct. Mm-hmm. Right, right. Okay. That's an interesting thing. It did not make it to top 3, I can say, this one. But, yeah, I mean, we could potentially, once we have an algorithm to pick up things and put things on the site, so to speak, because now it's just a table, so it's expecting data. Once we have this, we can then start and go and see if there's any way of kind of customizing it. So we kind of give you a possibility to, yeah, I'm just interested in this one, and this one. Period, right? Most of them, well, most of the customers don't want all that much, maybe, perhaps. At least we didn't hear so much demand for all those settings, default settings. You're right. That would be interesting to know, I guess. So, yes.